Axel Schwerdtfeger und Benjamin Knaus werden jetzt sprechen über Mobile Machine, Product or Component. Und die beiden werden online sprechen. Und ja, dann würde ich sagen, dann dürfen sie loslegen. Da sind sie schon, oder? Wenn ich das richtig sehe.
Hallo, guten Tag zusammen.
Guten Tag.
Hallo, guten Tag. Sie dürfen loslegen. Die virtuelle Bühne gehört Ihnen.
Gut, dann schauen wir mal, ob wir auch übertragen können, dass das alles klappt. Eine Sekunde, geben Sie mir bitte. Ich versuche das Zeitmanagement genauso professionell wie der Herr Sauerborn hinzubekommen. Begeisternswert hat er das gemacht. Also, wir gehen in die Präsentation und Sie müssten es gleich sehen. Vielleicht, wenn ich einen kurzen Hinweis kriege, dass es geklappt hat.
Ja, wir sehen es. Wir haben allerdings hier noch die Referentenansicht. Jetzt. Perfekt.
Wunderbar. Hello and good afternoon. Thank you very much for the invitation and the opportunity to speak here at the CMM. Today, you guys are talking about mobile machines and mobility, as well as the interactions of machines and the ecosystem in which these machines move. Today, we want to make a thesis. Should a mobile machine be a component to fit perfectly into ecosystem? Or should it be a specific product? In the past, for example, the cars and automobiles created their own environment. Gas stations have been created according to them, roads and parking garages, all fitted perfectly because the car was designed as it was. In the future, we expect that the demand of connectivity might shape and influence the design of vehicles much more. And this will create a different surrounding. The question is, should these components be created as a product or different? How does the picture we show now fit to the topic of today? It's not a mobile machine, even if it is creating mobile machines. It is the perfect example of an autonomous, networked ecosystems in the industry, consisting of main control systems, data connections, sensors, and actors, and the whole lot of robots. These robots is just a component which fully defined interfaces of data, mechanics, and sensor. I think future mobile systems will have a similar architecture, with vehicles like cars and tractors and excavators instead of robots. These vehicles and machines will be just components used in the network ecosystems. In the following slides, we want to show you what this means for our vehicle design by using exciting examples. And to give you an overview, who are you listening to? Actually, it was planned that Marco Bauer is taking the presentation today, but unfortunately, he is sick, like a lot around Munich in the moment, maybe because of the Oktoberfest. And that's why we take over. I'm Axel Schwerdtfeger, the CTO of the HAWE Group, in charge for development and product management. And Mr. Benjamin Knaus, he's division manager and the heart of robot. And I do not want to forget to give special thanks to Dennis Kirchner. He is right with you, and he brought the Rovo to you and is the guy close to you to answer the questions immediately and show the functions of the system. HAWE is creating usually HAWE hydraulic products like IoT-ready power packs, batteries and valves for all kind of use. With a very special configurator, we give our customers the possibility to use all these components to create complete machines. And if this is not enough, we also offer designs especially for customer requirements like this PPT. It's a power trim tilt system to trim and tilt very strong motors on leisure boats, but this is just one example. We are a company working worldwide. We have 2,600 people, have a turnover of 460 millions, and are located all over the world. We have 24 subsidiaries and a lot of partners. And the products we are talking today about today are created, designed, and developed in Schwarz in Tyrol in Austria. The starting spark of the foundation of HAWE Mattro was in 2006. In the early 2006, nobody was talking about electrification at that time. And Mr. Alois Bauer was the founder of Mattro, and he wanted to create real solutions to set an alternative to combustion engines, out of an ecological drive and out of the conviction that something has to be done to find solutions for the ecological change. So that's why he founded the company. And since then, a lot of happened. We designed battery packs which are interchangeable and combinable. We created vehicles with men up and without persons on board. We help people to create electrification projects. And since 2009, HAWE Mattro is part of the HAWE Hydraulik group. And we invested a lot. We opened up our new subsidiary in 2022 in Schwarz in Tyrol, where we have now the right surrounding to do our work. Mattro is creating solutions in 3 business units. One is the business unit to create accumulators. One are taking part to help our customers to leave the old times and reducing combustion engines and going to electrical drive. And the third one is creating vehicles. And now the question is, should these type of vehicles be complete products, finished and creating their surrounding, or should they be products? And to get into this topic, we thought it might be a good idea to do some comparison. Here you see 2 products. One is a type of our valves. It's called ROLV valve. It's a seated valve. And the other one is the ROVO itself. Cheeky but true, both products on the slide are easy to use components with specific interfaces and functions that are to be integrated into something larger. Let's take a look at the components in details. There are control interfaces. On the valve side, we have the Deutsch connector directly connected to the magnet at receiving signals. On the robo side, so on the vehicle side, we have data connections like bus systems, ROS interfaces, and so on. So pretty much the same. The functional interface. On the valve side, we have the NG6 flange pattern, what is a very common flange pattern for valves in the industry. And on the rovo side, there are a variety of options to mount different solutions, a power supply, and so on. So those can be compared. And then on the function side, we have the possibility on the valve to regulate flow. So this is the function of the valve, making sure that the oil is flowing into the right direction, back and forth. And on the vehicle side is even more easy. Actually, the only function is driving. And to be a right component, there should be also the possibility to add accessories. For example, additional check valves in the valve side, or for example, a hydraulic lifting or a power packs on the vehicle side. So on a very simplified level, both solutions can be considered as a component. And from our point of view, this is the right approach to give customers maximum freedom and integrate this component into a networked ecosystem. And to give you an overview how that works, we brought a small video and Mr. Knaus gives you the sound to it.
The easy swappable battery is the heart of our ROVO. It powers the motor and all the other components. As already mentioned, the ROVO is seen as just a component. It needs to be combined with other components to form a finished application. Adding additional hardware opens a wide field of autonomous applications. For instance, you can see here GPS waypoint navigation. This can be used for simple tasks like transportation, but also for more complex tasks, as we see in the following scenes. For instance, there are many possibilities in the inspection of infrastructure. The robo itself is highly capable of driving in off-road terrain and therefore can be used to inspect various infrastructure. Speaking of infrastructure, the robo itself can be used to create infrastructure itself, as it is a movable power supply. For instance, after natural disasters or in exploration. As I already mentioned, it can be seen as a mobile power supply, powering different tools or giving light or building up communication network, for instance, but also doing simple transportation tasks.
We believe that we need to build vehicles and vehicle parts so that they can be used as a component in different applications. They must adapt to the area of use and not try to shape the area of use due to their design. Why? Let's look at the construction site of the future. We believe in the future, every machine on the construction site, pretty much what we heard of the speakers in front of us, on the construction site must be part of a data ecosystem. Connectivity will determine how efficiently the machine can be used, how easily it transfers data to connected systems, and how it is using the received data to fulfill their duty the best way. The machine has to be one part of the ecosystem to give the chance to use all data in a perfect way and boost the productivity of a construction site. Let's look into another area. For example, agriculture. Here, mobile machines will interact in a swarm. Small individual deployable helper robots will take over a wide range of tasks alongside, with, and instead of humans. The machine must be perfectly adaptable to individual requirements. In this application, you can see small flexible robots, which in comparison to large tractors, barely exert any ground pressure. They operate in a swarm and make it possible, for example, to apply seeds very precisely. And here too, it is important that the platform adapts, enables connectivity and solve tasks. So the product itself is not changing the infrastructure, but the infrastructure has to be the chance to adapt, or the vehicle has to adapt to the infrastructure. My last example shows that the Robo is designed in the Alps. Mattro is homed in Tyrol in the Alps. Ski slopes, for example, are prepared today with a whole fleet of snowcats. But also in the tourism industry, there are less and less qualified workers, and therefore ways have to be found to prepare the slopes with few people. In our example, it is done purely electric, emission-free and quiet. Highly flexible platform, networked and in this case, particularly autonomous, can also offer a solution for this. In this setup, one worker can run a whole fleet of unmanned snowcats to prepare the slope for the next day. So by talking about these possibilities and the need to create platforms which are highly adaptable, we now get into more details, in more technical details, as we have for sure a lot of super interesting technical examples which might be interesting for all the engineers and technicians with this view. So Benjamin Knaus is taking over.
Thank you very much for the introduction. First of all, I would like to have a closer look on the Rovo as a component. A component usually is a part of a bigger system and is connected through an interface to other components. Our idea for the Rovo was a system that can ensure precise driving for customer applications. We wanted the Rovo to be adaptable and multifunctional, as we assume that the vehicle is not the leading system, but the infrastructure is. We decided to focus on that topic and don't spread our know-how too thin among other fields, but we created an environment tailored to the needs of our customers and partners. Next. This means that our component, first of all, has to be able to fit the mechanical needs of the customer. The Rovo should not only deliver as many attachment points as possible, it has to be able to shape itself to the application. The basic version of the Rovo starts with the most basic components. The chassis is the most important mechanical part. It houses the battery and is mounting platform for the track system and the electronic box. On top of these components, various mounting adapters and frames can be placed. Also, options like hydraulic hardware are available to deliver a wide range of possibilities. As Mr. Schwerdtfeger mentioned before, hydraulic is looked at as a component as well. To sum this up, we tried to not only provide one single solution for one sole purpose. The goal was to let the customer decide how deep the grade of integration from our side should be. Modularity is not only a hardware or mechanical topic, but also a challenge for electronics and software. Next. When we talk about electronics, we first of all think of our lithium-ion battery system. But this itself would be worth speaking about in its own keynote. Now I only want to mention that our battery swap system leaves the choice on range and working time to the customer. For autonomous applications, we also have further options, like inductive charging solutions. When you design a finished product for a single purpose, it's relatively easy to choose components like motors and controllers. If you look at the topic from the component point of view, you have to take care that you ensure enough flexibility to fit as many applications as possible. You have to make sure that you don't lose track on and make too many compromises. For the Rovo, for instance, we found a motor and a motor controller and a gearbox bundle that provides various possibilities for different applications. At the moment, for instance, we have two main variants, one for high speed and one for heavy loads. Next. As the Rovo really is a power supply on tracks, we ran into the question how we should supply external power for the customer's applications. In the past, we did so by customization for every single application. The learning was hard, but for the new generation, we improved and implemented standardized power interfaces. But not only choosing the right interfaces is important. It may sound self-evident to place an interface like a plug in a place where it is easy accessible for the customer. With the extreme wide range of possible applications of the Rovo, it's not that easy. The solution was to reduce the number of interfaces to an absolute minimum and try to give every interface not only one use, but if possible, more than that. So for instance, a signal plug is also exchangeable by a low power plug. And the charge plug is not only usable for charging the platform, but also to supply external attachments with high power. Next. Speaking of modularity, we also have to look at software and related topics. We needed to learn that it's not enough to just tailor the software to the needs of every single application. We started this standardization by applying two different layers of communication. One for the internal vehicle communication and one for the external communication between customer and vehicle. This allows us to update and support the drive software and safety features of the Rovo without interfering with the customer. On the picture, you see the Rovo layout on the left side and the example customer system on the right side. The Rovo always keeps its standard, with standard options for every customer. The right-hand side, nevertheless, can be entirely tailor-made. To make sure that the robot can be operated safely and precisely in every single use case, we decided to create a clear software interface as well. The customer is able to externally control the robot via CAN bus with a defined protocol. Steering the robot is as simple as sending direction of rotation and rotations per minute to the robot. This opens a wide field of possible applications, especially under the topic of autonomy. Autonomy or autonomous applications are huge words. We all know that there is more to it than just finding the right components. But finding these components is a basic requirement, and the robot proves to be just that. To keep it short, I just want to give you a rough overview of what's already possible with the robot. Implementing additional sensors and intelligence leads to functions like gesture control, follow me mode, GPS waypoint navigation, teleoperation, and semi and fully autonomous applications. You could ask why we as HAWE Mattro are relying on partners for autonomous applications instead of doing it ourselves. As we see the robot as a component, in our opinion, autonomy is a component as well. But let's have a look on some projects. Next. One of the most challenging applications we've faced yet was mapping in underground mining sites. The degree of autonomy is directly related to safety and reduced human presence. It's not enough to put a good LiDAR on top to be able to map the mining site. As you can imagine, there is no GPS signal available for localization. The vehicle must be able to locate itself, recognize obstacles, and potential hazardous situations. Due to teleoperation, of course, it is possible for a human being to step in if necessary. Because such mining sites can be real huge, a solution to increase the range of the robot is needed as well. Inductive charging comes in handy at this point, because it's one of the easiest ways concerning automation without human interference. The Alpha Wolf, as an example, is a multifunctional robot for firefighting purpose. It is used for search and rescue, reconnaissance, safeguarding, and of course for firefighting. To be able to do so, it is equipped with a great amount of hardware and connected to a mobile mission control center. In this mission control center, every single piece of information is collected and processed to the needed task. The challenge on this project was to integrate the robot in a mobile and flexible infrastructure. It not only provides information about location and speed to itself, but for example, has also integrated sensors for temperature and gas detection. And not to forget about the water hose it has to carry through the wilderness to be able to fight the fire in the end. The Pixel Runner is a quite interesting piece of hardware. Its purpose is to print huge-scale marketing messages on grounds like grass, asphalt, and snow. For example, in sports stadiums or on Formula 1 racetracks. This comes with various challenges in localization and precise steering, especially if you think about a 3 × 3 centimeters small pixel, 3 colors, and more than 100-meter long logos. These requirements were met by a heavy-duty motor gearbox unit and tailor-made motor controller parameters. To come to an end, a component does not only have to be modular, flexible. It is also very important to keep it as simple and accessible as possible. The goal is not only to make it possible, but also to keep a project fast and at low cost. Only then we are able to face future challenges, like more and more automation and autonomy. If you need a component to move your application in harsh environment and rough terrain, you are warmly welcome to get in touch with us. And with that, I want to thank you for your attention. I know it was a long day full of information, but if you have any questions, we would be glad to answer them.
Okay. Yeah, well. Thank you very much. That was quite impressive, and it was good to see now all these slides on all the information about the robot that we could see the whole day outside. And yeah, are there any questions? Gibt's Fragen? So what I would like to know is, I mean, working with HAWEs is always a question of acceptance. The acceptance by the workers and the staff that are working with it. So what did you experience with how is your technology and how are your robots accepted by workers, by the companies and so on?
Actually, as we do mainly outdoor applications, we are not so much directly interfering with workers. Yeah. But for example, the firefighting robot, he's directly in direct connection with the firefighting guys, and they really appreciate having this this robot in close cooperation, as they do. As the robot is doing the ugly jobs, and they have the possibility to step away from the hazard zone. So we made good experience so far.
Okay, okay. Good. So thank you again. As I said, it was a really very interesting, impressive lecture, and thank you for your time.
Thank you for the chance to talk to you.
Thanks.
Have a good day, and hopefully you enjoy the robo at the site.
Yeah, we do. Thank you.